Hi and welcome to this lesson on simultaneous equations. Let's see if we can simplify simultaneous equations for you. And before I tell you what it is, let's just look at what is a normal equation. Okay, basically in the past we've told you that if I have an equation like 2x plus 1 is equal to 5, the idea of this equation is to find the unknown so that the left hand side is equal to the right hand side. So in this one you can see if x is equal to 2, then 2 times 2 is 4 plus 1 is equal to 5. So the solution to this is x is equal to 2. However, there would other ways in which we would solve this. For example, we would subtract a 1 on both sides so that I have 2x is equal to 4, and then we would divide a 2 on both sides in order to get that x is equal to 2. Okay, that is how we would use some methods to solve this unknown. Now, in simultaneous equations, what we will have is we'll actually have two unknowns. So let me do it this way around. Let's say I already had my answers. I already know that x is equal to 2, and I already know that y is equal to 1. Okay, now I can say something like that means that x plus y is equal to, well, x is 2 and y is 1, so x plus y would be equal to 3. Okay, or I could say something else. Well, if I multiply y with a 2, it will have the same answer as x. So in other words, if I take 2 y's, I will have the answer for x. Okay, and this is an example of simultaneous equations. I've got two equations, and here's the two equations, and I want to know what is the solution for x and y. What values can x take and what values can y take so that these two equations are true at the same time. In other words, when x plus y is equal to 3, well, that means that x can be 3 and y can be 0. But then this one isn't true because x is 3 and 2 times 0 is not equal to 3. So even though 3 plus 0 is 3, okay, 2 times 0 isn't also 3. Okay, so there can be multiple solutions, but in the questions that we are going to look at, there will only be one unique solution to our simultaneous equations. So how would we do it? Well, I'll give you the broad overview first. What you want to do, or actually the goal is to get an equation with one unknown. Okay, and in the linear equations that we're going to look at, linear means our unknowns have their exponents. That's not 0. I wanted to show the exponent. The exponent for our unknowns are 1. Okay, the exponent for the unknowns are 1, then it's a linear equation. So what we want is we want to get an equation with one unknown. So here you can see we've got an equation with two unknowns. Here we've got an equation with two unknowns. And in order to get, as soon as I have an equation with one unknown, I'll just do what I used to do. I'll just solve that unknown in the normal way. Once I have that unknown's answer, okay, so then I'll find that answer, and once I've solved that answer, I'll substitute the answer into any of the equations. I'm just going to say EQS, equations. Okay, if I knew that x was equal to 2, if I worked out x is equal to 2, then I can just substitute x is equal to 2 into the equation, and when I divide both sides with a 2, I get y is equal to 1. Okay, so if I have one of them, it's very easy. I just solve that one, and then I substitute it into the other equation, and obviously I then solve that one as well. Okay, now the method actually comes in at this point, because I mean from here on it's very easy. The question is, how do I get, using these two equations, how do I get an equation with one unknown? Okay, now here's an example. X plus y is equal to 3, y is equal to 1. This is also a simultaneous equation. Okay, we've got two equations, 1, 2. One of the equations have more than one unknown. This one only has one unknown, so I've already done this step. I can just go on from here. But what if I don't have something like that? What if I actually have something like here, 2y is equal to x. Now we already know what the solution is. I'm just using this known part to actually show you that how will we actually get these answers. Okay, the two ways in which I can use two equations to get one unknown is I can either do the substitution method, or I can do the elimination method. Okay, and I'll show you both here. Now, what the substitution method is I'll solve an unknown. Okay, in other words, I'll choose one of them to solve. In this case, we already have x is solved. X is equal to 2y. I already have one of the unknowns all by itself. So this would be the easiest method to use to solve this. Okay, after I've solved the unknown, I substitute this unknown, which x can now be substituted with 2y. Substitute into the other equation. Okay, so let me show you that method. So we have x plus y is equal to 3. Was that true? Yeah. And then we have that 2y is equal to x. So what I'm going to do is I'm just going to give each of these equations a number, so that when I do something I can tell people that are reading my question exactly what I'm doing. I'm going to call this one equation 1, so it's 1 with a little circle around it, and this one I'm going to call equation 2. Okay, after I've numbered them, I'm going to say what I'm going to do. I'm going to substitute equation 2 into equation 1. What do I mean by that? Well, equation 2 tells me that everywhere where I can see an x, I can replace that x with 2y. So in this top equation, I can go say x plus, and then instead of instead of x, I can put 2y. So I've got 2y plus y is equal to 3. Notice how all I did was to replace my x with 2y. Now I add them together, I get 3y is equal to 3. So y is equal to 1, because 3 times 1 is 3. So I've solved the one. All I need to do now is substitute to solve the other one. Now usually you just substitute in the one you originally solved. X was solved, so I've got x is equal to, and again let me do it the correct way. I can rename this one, this is also equation, I can rename this equation 3, and I can just say again substitute 3 into, and it can be any one of the two. Look, if I substitute equation 3, in other words y equal to 1 in here, then I get x plus 1 is equal to 3. So if I solve it here, I subtract a 1 on both sides, and I get that x is equal to 3 minus 1 is 2. Okay, I'm going to choose this one, and you'll see you get the same answer. If you don't get the same answer, you made a mistake in your previous step. So I'm going to substitute it into equation 2. So equation 2 says 2, everywhere where I see a y, I replace it with 1. So 2 times 1 is equal to x, so x is equal to 2. Okay, that's a great method, and the reason why I showed this method first is because it will almost always work. Okay, I say almost always work The only reason why it might not work is when you can't solve if you can't get one of the unknowns on its own. For linear equations, you can always get an unknown by itself. It's never a problem. It's when you have two equations and neither of the two equations are linear that you might have a problem, but you will never have the problem. You can always use substitute solve method. Okay, now how about the elimination method? Elimination method means that I'm going to use the two equations and I'm going to eliminate one of them. What do I mean by that? First, what you do in elimination is you get the equations in same form. Okay, what do I mean by that? Well, to get equations in the same form, if this has the x term first and then the y term and then the constant term on the other side, I want to do the same for this one. Okay, so I will start by saying x plus y is equal to 3, and I'm just going to use this form. Okay, then this one, the x is on the wrong side of the equation. I'm going to subtract it on this side and on that side. Okay, so then I get negative x plus 2y is equal to, and now on the right hand side I used to have x, but I subtracted that x, so I have nothing left on the right hand side. Okay, once you have that, the next thing you must do is get one unknown to have the same coefficient, but opposite sign. Okay, we're lucky we already have that. Notice how this one's coefficient is 1 and this one's coefficient is -1. The reason why we want this is because in the next step what we're going to do is eliminate this term. Okay, and we will do that by saying, okay, I take this as number 1, I take that as equation 2, and I'm going to say, let's just add these two together. Let's just say equation 1 plus equation 2. Okay, once I've added those two together, look what happens. Okay, I add the x terms together, the y terms together, and the constant terms together. So 1x minus 1x is 0. Y plus 2y is 3y. And on this side, 3 plus 0 is 3. So I've got 3 times y is equal to 3. That means y must equal 1. Okay, you can see it's quite a bit shorter method than this one. However, it's slightly more complicated, especially when you can't get the same coefficients. Let me show you another example, and I'll show you, because after this we add the two equations. Okay, and once I've solved the one, okay, so I solve one variable, and then of course I go back to the same method that I did here. I just substitute. Once I've solved one of them, I just substitute it into the other one, okay, which I can now say we'll call this one 3, substitute 3 into, and now you can choose whichever one you think is the easiest. This one looks easiest to me, so I'm substitute 3 into 1, so x plus 1 is equal to 3, so x will be equal to, subtract 1, x will be equal to 2. There we go. So after we've solved one variable, we'll solve the other. So, well, let's say sub and solve the other. Okay, cool. So what do I do? What do I do here? If I want to use elimination method and I don't have it so easy, I don't have my two equations with the same values, what do I do then? Well, let's look at the same equation. Let's say I had that 2x plus 3y is equal to 7, and 3x plus 2y is equal to 6, 7, 8. Okay, let's say these were the two equations I had to solve. Now you can already see that if I want to use elimination method, my first step is pretty easy, okay, to get equations in the same form, because I already have that. I've got x's and y's and constants all in a nice form. The two are the same, so I can just go and call the one 1 or the other one 2. Let's say 1 and let's say 2. The problem though is that neither of the coefficients are the same but opposite. Okay, so what I'm going to have to do is find a way to get one of the coefficients to be the same as the other one. Okay, and you can choose either one. What I'm going to do is I can see, well, there's no way I can turn a 3 into a 2, okay, by multiplying with, well, there is a way, but I want to multiply with integers, okay, and there's no way I can get a 2 multiplying with an integer into a 3. But what I can do is I can make both of them into a 6. How will I do that? Well, I can just multiply 2 with 3. I can do that in an equation as long as I do it throughout the whole equation. So multiply equation. So I'm going to take equation 1 and multiply with 3. Everything gets multiplied with a 3. So I get 6 times 3, 2 times 3 is 6x. And then the next one, 3 times 3 is 9y, and the next one, 7 times 3 is 21. So this would be my new equation, equation 3. Now I can still see these two don't look the same. I still have to change this one as well. So I'm going to take equation 2 and I'm going to multiply, and this shouldn't have been circled, I'm sorry. I'm not multiplying with an equation, I'm multiplying with a number, so I apologize. That should be a 3. If I'm talking about equation 3, I'll circle it, okay, but I'm multiplying with 3. What I'm doing with equation 2 is I'm going to multiply with 2 because I want this to be 6. But now one more thing, if I have it as 6, then I've got 6x, 6x, and I actually want one of them to be negative, so I'm going to multiply with negative 2. Okay, so negative 2 will make this negative 6x. Negative 2 times 2 will make this negative 4y, and negative 2 times 8 will give me negative 16. Great, now I can see I can eliminate the coefficient of the x terms by adding, I'm going to call this 4, by adding equation 3 and 4. So equation 3 plus equation 4, I will just add everything together. So 6x minus 6x gives me 0. 9y minus 4y gives me 5y. Okay, equals to 21 minus 16 gives me 5. And there we go. All I need to do now is divide both sides with 5 to get that y is equal to 1. As soon as I have the value for y, I can substitute into any one of the two. So I'm going to say 2x plus 3 times 1 is equal to 7. So this one solves 2, x is equal to 2. Great, I hope that was the bulk of it. I'm sure it's really not that difficult. In the next video I will look at what do we do if one of the two equations is actually a quadratic equation. Okay, so if both of them aren't linear, what do we do then? I'll see you there.